Hello everyone. Welcome to another session. Thank you, Dr. Baday, for the introduction as always. Thank you, sir. So today we are going to work on KNN. So we had these workshops before. If you remember, if you have attended, I don't know. But the workshops on building machine learning algorithms from scratch. I think it's a good exercise to understand, have a deeper understanding of the algorithms, basic algorithms, and also practice some coding. Now, one thing is live coding is always difficult. I always have issues when I'm doing live coding. So if something doesn't work as expected, forgive me, please. I'll do my best, okay? So let me share my screen. Let's see. Oh, not this one. There's so many things open, so I think this one. Yeah. Okay. So I hope you guys can see my screen, and let me take care of this one too. I'm going to be seeing your questions. If you can post your questions to Q&A, not to chat, so I can see your questions, because if you post on the chat, it might get lost. So sorry if I don't see your questions. All right. But if you can post your questions to Q&A, I'm going to do my best to answer your questions. You don't need anything, any file, any data for this workshop, only a blank Jupyter notebook is going to work fine. If you don't have Jupyter installed, you can simply open Google Colab, all right? All right. Okay, so let's get started. First of all, when I work on the basic machine learning algorithms, there are three basic functionalities I expect from an ML algorithm, right? So it is going to fit, right? It's going to fit my train data set. Right? And this is a supervised model. And then I'll be using my, what is that? Labels. And it is also going to predict. So this prediction can be X train or some X tests. Okay. And it is also going to give me the score, right? So when I ask for the score, again, I'm going to be putting my X test data set and also the corresponding labels. So the score is going to compare my predictions for X test, which is going to be Y hat test with Y test, right? So these are the three basic functionalities I will be expecting from any machine learning algorithm. So of course, there are more methods, more attributes. We can add a lot more, but these are the basic three functionalities. So I'm going to use this information, right? So this expectation to write my code. Okay, so what are we going to do today? We are going to be writing the code for having a KNN, which is K, let me write it explicitly, nearest neighbor plus 5. So the regressor is going to be similar, but the regressing part is going to be different than the classification part. So I'm only going to focus on classifier. If you like, later on, we can also look at regressor. Okay, K nearest neighbor classifier. If you guys remember what K nearest neighbor classifier is about, it's one of the simplest, most basic algorithms that maybe the first algorithm we learn when we learn machine learning. So what we basically do is, given some n number of data points, and then given some new test data point, what we want to do is, if we want to predict the class for this new data point, I'm going to compare this new data point with all the data points I have in my training data set. How that comparison is going to work, I'm going to find the distance between this new data point and all other data points in my training data set. So let's say I have 100 data points in my training data set. I give you a new data point. You're going to measure the distance between this new data point and each and every 100 data points, and then pick the K nearest data points to this new data point. Okay, say given 100 data points for training, given 1 data point for testing. Okay. And then what I'm going to do is measure the distance between the test data point and each and every training data point. Okay. So these are the things that we're going to do, right? So we're going to measure the distance. And how we're going to measure the distance, we're going to see in a moment. And then pick the nearest K. So it can be nearest 1, nearest 3, nearest 5, nearest K data points from the training data points. Okay. And assign the majority of the classes in assign the majority of the classes from the K nearest data points to assign the majority of the class from K nearest data points to as the prediction as the I'm going to go to the next line, prediction for the new test data points class. Sorry about the English. I hope you guys understood what I'm trying to say here. Okay. I think this is what we're going to do. Okay. I think this is what we're going to do. So there is a question here. If you have a moment, can you go briefly over the difference between the fit function and fit transform function? So this is about scikit-learn. What scikit-learn does is scikit-learn. It's this very rich open source machine learning library, right? So we have estimators and transformers. Both for estimators and transformers, we are going to use the fit method. Fit method is going to fit our data to some model. Okay. For transformers, so we need to first fit and then transform. Okay. If you like, you can first fit and then transform, or you can simply say fit, transform. So this is basically going to fit and then transform your data points. Okay. Does KNN algorithm actually have a training phase? Okay, so this is a good question. The training phase so let's go back to our 3 main functions, fit, predict, and score. Now, the question is about this fit function. And let me take this down over here. So fit function for the K-neighbors classifier is extremely simple. What happens is simply copy X train and Y train. That's it. So this is how we train the model. So basically, the model is so simple, okay? So the training the model is very simple. Just copy the data points to your environment. So that's why K-nearest classifier is going to take longer and longer to classify a data point. K-nearest classifier is going to take longer and longer as the size of your training data set increases. So it's going to be inefficient when you have a really large data set. We'll see that. Okay. Again, please post your questions to what is that? Q&A. I'll try my best to answer your questions. Okay, so let's continue. Let's then begin from this fit function. Okay, but before we begin with the fit function, I want to create a class. Okay, so let's create our class. So class K. I'm going to call my class KNN because later on I'm going to use scikit-learn's K-neighbors classifier to compare our method with our class with scikit-learn's class. So I'm going to create a class KNN classifier. KNN, let's call it KNN classifier. Okay. So inside this class, I'm going to have a number of functions. The first function that I'm going to write is the init function, right? Which is going to be initialized whenever we create an object from this class, right? So this init function, of course, comes with self. So for K-neighbors classifier, we have one parameter. one hyperparameter, which is very important. What is that? For k-neighbors classifier, the parameter that we are going to choose for our classifier is k. What is k? K is, after we measure the distance between our test data point and each and every data point in the training data set, k is how many of these training data points, the closest training data points, how many of them you're going to pick to predict the class for this new test data point. Okay, that how many of the training data points, the closest training data points, that number, how many, the answer to that, how many, is actually number of neighbors. Okay, so this is not neighbors, no neighbors. So this is my, what is that? My hyperparameter. Okay, so let's write, it's very simple. So let's write this self dot number of neighbors is number of neighbors. By the way, I'm pretty sure among you guys, there are people who can write this code much more efficient and better. I'm pretty sure about it. Okay, number of neighbors is number of neighbors. All right, next. So we initiated our, when we instantiate our object from this classifier, so this function is the first thing that will be running. And then we create the object itself, which is self, and then we also take from outside number of neighbors. So somebody will pick, whoever initiates this classifier will give us what the number of neighbors is gonna be. It's 3 or 5 or 7 or 11. Which one is best? That's called hyperparameter tuning. That's another story. Now let's work on the fit method. Okay, fit method. So let's call it def fit. For the fit method, because inside the class we are defining this, let's first write self. For the fit method, we need two things, right? This is a supervised model. We need two things. One is the training data points. The other one is the training data points corresponding labels. So let me take them. X, I'm going to call them train, and then Y, train. I'm calling them train just to let you know that when I fit, I'm fitting my model on the training data set. Okay. All right. So again, this fit function is extremely simple. What it does is it simply copies the training data set, right? And then the corresponding labels. And then it returns set. Basically, I'm just copying X train and Y train from outside into my class. So in practice, is the choice of which distance function to use another hyperparameter? Michael, that's correct. That is correct. So there are more parameters actually. So the choice of which distance function we're going to be using. So in this class, we're going to be using Euclidean, but you can use Manhattan distance function or some other distance function. Yeah, that is another hyperparameter. Actually, if you go to scikit-learn's k-neighbors classifier, you will see a number of parameters that you need to pick. But k is the hyperparameter that we mostly focus on. Okay. All right. Michael, please go ahead, ask questions. Thank you. So this is the fit function. We are done with the fit function. Now it is time for us to go to the next method, which is, let me go back. So predict. Okay, so let's try to write predict. Okay, so this time to predict, what I need is, I need, of course, self, and then I need my test data point. So think of this test as a number of data points. So I can give you 100 new data points and ask you, can you please predict the classes for each of these data points in my test data set? Or X test can be a single data point. So X test is going to be a NumPy array of it's going to be a NumPy array, okay? And then you're gonna give me, if whatever you're classifying, okay, you're going to give me the values for the attributes of that subject. So let's say we are going to later on in this class, we are going to classify iris. We're going to use iris data set to classify flowers into 3 different groups. And as you know, iris data set is the data set that is most well known in machine learning domain, right? So that data set comes with 4 attributes. 4 columns, right? X1, X2, X3, X4. For each data point, I have 4 features, right? So let me write them X1, X2, X3, X4. Somebody is going to give us the measurements for these 4 features for a single data point, okay? So that is going to be the input for this X test. And by the way, this can be many such data points, okay? It doesn't have to be only a single one. And another thing is its dimension is going to be 2, not 1. You might also have this error message if you enter your test data point as a single dimensional array into scikit-learn's estimators. Okay? So it's going to be 2-dimensional. We'll see in a moment. Okay, so I'm going to predict y hat for this X test. Okay, I'm using the terminology. I'm assuming that you guys are familiar with this, but let me still just explain y hats and y. So what is the difference y hat and y is the true label, y hat is the estimated, the predicted one. Okay, so here I'm predicting y hat, and later on I'm going to compare y hat and y. Okay, so to predict, on time checking the questions, to predict what do I need to know? First of all, I'm going to assume that my test data set is a matrix. In other words, I'm going to have multiple data points. Then my prediction is going to be returning a list. So let me say my prediction is an empty list. Okay. And then I'm going to populate this list for each prediction for each row from my X test. Okay. So for that, I will go over each row in my test data set. Test row in X test. Okay, so I took X test data set. It is a matrix. It is composed of many rows. Row 1, row 2. Now I'm gonna go through each row. So this is X1, X2, X3, X4 is one row. So let me call this X11. So it's gonna be easier for us to. And this is X12, X13. This is the 4 features of the first data point, and then I have the similar thing now. For the next data point. This is the second data point. Okay. Sorry. All right. So I will go, let's assume this is one single data point. I'm gonna first do my prediction for this one, write the prediction or append the prediction into my pred list, and then I'm gonna go to the next row and then the next row. Okay. Very good. So now I'm gonna be working on this row, single row that I got from my test data set. So for this single row, which is representing one data point, remember what I was supposed to do? I tried to write what we are going to do here, right? Remember what we are supposed to do? We are going to measure, oh gosh, what measure, right? We are going to measure the distance between this row, this single row, one single data point, and each and every training data point. That's what I'm going to do. That's the first thing. Second, I'm going to pick the nearest K of these training data points to this single test row. Okay. And then I'm going to check the majority of the classes among these K neighbors and then assign that majority class to this test row. That will be my prediction. You see, I need to measure the distance, and then I need to find the nearest out of the training data points, K nearest out of the training data points to this data point. So I need to do 2 things. So let me systematically, okay, approach this problem. So first of all, I'm going to find the neighbors. So let's call this neighbors. Okay, so I'm gonna find neighbors for this data point. Okay, these neighbors will be changing might be changing for the next data point. So neighbors. So for the neighbors, I need some function, okay, who is going to find neighbors. Now I'm talking about some helper functions, okay? Remember, my main functions are fit, predict, and score, but for predict, I need some additional things. If you like, you don't have to write an additional function, but I think it's gonna make our code readable if we write our functions. So for that, maybe let me write the functions here so that I will still observe the sequence of fit, predict, and score. Okay. So I'm gonna write a new function here. Okay. This function, I'm gonna call it find neighbors. Okay. Find the neighbors. So find neighbors of what? I'm going to find the neighbors of my test role. Okay, so I need this guy here as an input. I'm gonna find neighbors of this guy. Okay, let's do it then. So how am I gonna find the neighbors of this guy? What I'm gonna do is I'm going to, first of all, get number of neighbors. So number of neighbors. This is coming from my class self. And by the way, because this is a function inside the class, I don't forget adding self into it. Okay, so I got my number of neighbors. What else? To find the neighbors, I'm going to get xtrain. Okay. Again, this is coming from, let me put some space here. This is coming from my fit in here, right? I already got xtrain. And then what else? I will get ytrain. Okay, so I got everything I need now, right? I got the number of neighbors and I got my training data points with their corresponding labels. I need the labels too. I need the labels of the neighbors as well, right? So I also have test row given to me. Perfect. Now let me find the distances. Again, distance is going to be another list. So distances. Okay, it's going to be another list. And I'm going to find distance between this test row and each and every data point in my training data set. So for that, what I'm going to do is I'm going to run a for loop. So for all the data points in my training data set. So let's call this train row. Okay, for all the rows in my train data set. Now this train row is a single data point in my train data set, but I have to go over all the data points in my train data set and measure the distance between this test row and train row for all train rows in the train data set. Okay. And also what I'm gonna do is I will also keep track of the label for this train row data set. Okay, let me also put here. I'm gonna call it YJ. You can call it anything. Okay, I'm gonna call it YJ. And this for loop is going to run in a zip tuple of xtrain and ytrain. So basically, what I'm doing is I'm taking the first row of xtrain and its corresponding label. The first row of xtrain will be train row. The corresponding label will be YJ. And then in the next execution of the loop, I'm going to take the second row and the corresponding label, and then the third row, and then the fourth row. Okay, that's how we're going to do. Okay, perfect. Now, the next thing is I'm going to find the distance. Remember, I'm going to find the distance between this train row and also this test row. So let me find the distance. Let me call it distance is the distance between, let's for now assume that we have some function which is going to help us find distance between two data points. Let's assume that we have such a function. Okay, so, and then to make it simpler for us to remember, let me also say that here, so follow a sequence here. So let me write a function here, okay? And this function is going to find the distance. Let's call this, now going back to Michael's comment. So I'm choosing to use Euclidean distance. Okay, Euclidean distance. So Euclidean distance between self. For now, let me just leave it like this. Okay, for now. Let me just leave it like this for now. We're going to come back to Euclidean distance. But let's assume that we have this distance function already available and working. So I'm going to use this distance function here. Okay, self dot Euclidean distance. So what am I finding? The distance between the distance is going to be between the test row and train row. So let's write it, test row and train. Perfect. So I got the distance. Okay. So now I'm going to append this distance to my distances list. So let's do that. Distances.append. So I got my distance, okay, for each train data point, between each train data point and the test data point. So right now I'm assuming that I'm working on a single test data point, because here I'm gonna be doing one by one for each test data point in my test data set. Okay, so do you have any questions, by the way? Anything you want to add? Please feel free to ask questions. And then let me know if the pace is okay, all right? So I can go faster or slower. Please let me know. So I was right here. Okay, let me also get rid of this. Okay, I hope you can see the screen better now. So one thing that we need to be careful here, right? One thing that we need to be careful here. So train row yj in zip extrain, can you explain this? Yeah, sure. So here I'm gonna pick a row from my xtrain data set, and I will also pick the corresponding label for that row. Again, remember, xtrain data set is a matrix composed of rows, each row corresponding to one data point. Ytrain is the corresponding label for that. For example, I have the GPA and what is that? The GPA and then the school of a student. Ytrain is her like whether the student is sophomore or freshman or senior or junior, right? So I pick one student here, that is xtrain. One row from this xtrain is one student. Ytrain is whether that student is sophomore or junior or senior. So this train row is corresponding to that student, and yj is that student's label. Okay. So the next row, the next line, I found the distance between that student in my train data set and the new student, which is the test data set. Okay, I got the distance. Now remember, this distance is just one number. Okay, it's just one number. How do we find distance? It's right here. We have not completed the function to find the distance, but it is very simple. No worries about that. Let's assume that it is given already. Okay, so distance is a single number, but I need to also keep track of what is this distance? I mean, between which train data point and its corresponding label for this distance, right? So I need to also, I want to keep track of which training data point, for which training data point I got this distance for this test row. Again, test row is one test data point. So because of that, what I'm gonna do is I am going to put everything into a tuple. So here is what I'm gonna do. I'm gonna get my train row, and then, and then I'm gonna get yj, and I will get distance. So what am I doing here? I'm gonna explain. I'll try to explain in a moment. 1 second. Okay, so I got this y test. It's a y test row. I'm sorry. Let's do this way. Test row. It's a single data point. I am trying to predict her class. Okay, this is a student. I don't know whether she's junior or senior or sophomore. I'm trying to predict her class. And then I have some students that I know their classes, and I pick one of those students. I pick one student. That is train row. This is one of the students that I already know. I already know her class. So here is this one student, and I know that she's a senior. Okay, I know that she's a senior. Okay, I know this student and her class. So what I'm gonna do is I'm measuring the distance between test row and train row, okay? And this distance is called dist. I just gave the variable, assigned the variable dist. So this is just a single number. So what I want to do is, now I measured the distance, but I don't want to lose this information because this information is a distance between this specific student with this specific class and between this specific student and test row. So what I'm doing is, I'm going to put this student's information and her class, I know that, and this distance, okay? I'll keep track of that. So later on, when I find the nearest neighbor, okay, if this is the smallest distance, which is between train row and test row, then I will automatically know the class of this nearest neighbor. Okay, that's why I want to keep track of that. So that's why I'm doing this. So this distances will be a list of many tuples. Okay, so this is, let's say, train row 1. This is y1j, this is distance 1, and I'm going to have another one. It's important to understand what this is, so because I'm going to use it, okay, in a moment. Again, you can write this code in many different ways. Right? Two. So this is the second listing, and then formula. All right. Okay, so so distances list is populated. Now it is time for me to find the neighbors. Okay, after I populate all the distances, now I'm going to find the neighbors. So I'm going outside the for loop. I got all the distances. I'm not outside the for loop. I'm checking the X-train from find neighbors should be one variable from the init method. No, so I am going to, so you can do that, you can do it that way, but I'm going to enter X-train as part of fit method. Okay, fit method. YJ is not used, but here I am using this here because I want to keep track of YJ for this data set. Again, you can do this in a different way too. Okay, so, okay, now I'm outside the for loop. I found all the distances between this specific test row and my training data points. Now let me sort my distances. Why am I sorting my distance? I'm trying to find the nearest neighbors. First, let me sort the distances, and then I'm going to pick K of these nearest distances. Okay, so how can I sort my distances? So here is my distances, and let me sort it. So I had some examples here to show you how to sort it. Let me look at my notes so that I'm not going to waste your time. I created an example before. Okay. So let me just write an example here. Okay, sorry if it doesn't work. All right. So let's assume that I'm going to create a list of tuples very similar to what I'm doing here. Okay. So I'm creating a list. Let's call this Z, and this is 13 and -2. As you see, it's a tuple, right? And then there is another tuple which is going to be 4 and 5, and then let's assume another tuple 1 and -5. Okay. So I have 3 tuples. Now I'm going to sort this tuple. Let's see how it's going to be sorted. And then let me see how Z is going to look like. Now, as you see, the first tuple is 13, then 4, then 1. Now, after sorted, as you see, the first number is 1 because I am sorting based on the first number in the tuple, right? It's in ascending order. 1 comes, and then 4 comes, and then 13 comes. I didn't even consider the second elements of the tuples. Now, if I ask you the question of, can you sort this Z based on the second elements of the tuples, not the first elements, the second elements? In other words, the first tuple is going to be, again, 1, -5, because -5 is the smallest, but then the second element is going to be 13 and -2 instead of 4 and 5. Can we do that way? Okay. So the answer is yes, we can do it that way. So that's why I wanted to show this example. Again, I'm gonna be sorting, but I'm gonna doing this sorting based on a key. And what is that key? Key is gonna be a lambda function. What is a lambda function? Please search for it, okay? It's very simple, search for it. So I'm going to create a function here, okay? And so what this lambda function is gonna do is, it's going to take some variable called a, and it's going to take the second element of this variable, okay? So basically, sorting is gonna happen based on the second element of whatever this a is. Here, a is gonna be each of these tuples, okay? Now let's see if z is gonna be sorted as we expected. Yeah, so now it happened as we expected, right? So the first tuple is 1, -5. Now we are sorting z based on the second elements of the tuples. -5, then -2, and then 5. So the reason why let me copy this, we're gonna use this. The reason why I tried to explain this one is we're gonna use this to sort our distances. So remember, distances is a tuple, is composed of tuples. Each tuple is actually the training data set, the features of the training data set, its label, and the distance between this training data point and the test data point. But I want to sort these distances based on this one and this two. Remember, I'm trying to find the k nearest neighbors. So let's do it then, okay? So I'm going to copy this. I'm gonna be sorting distances, and then my key is lambda, and instead of the second element, this is gonna be based on the third element, right? I mean, third element, 0, 1, 2. You are with me, right? You guys are with me. Please let me know if it is not clear at any point, okay? So I hope this is clear, this one, why we are doing this. We are sorting the distances based on the third element of each tuple. Remember, the tuples are my training data points, each data point's corresponding class, and the distance between that training data point and the test data point. Perfect. So I got my distances sorted. Now, from these distances, I can pick the first k, right? Because I sorted my data points based on the distance from the test data point in ascending order. So I can pick the first k. So then let's do that way. So I don't know how many neighbors. So for k in number of neighbors, again, you can write this code much simpler, this part, okay? I'm just expanding it. For k in number of neighbors, let me use a range here. So I'll do this multiple times, right? So what I'm gonna do is I'm going to take the neighbors. Again, this neighbors is only for this test data point, okay? So neighbors, remember, was supposed to be an empty list. So let me create an empty list for neighbors. Okay, so I'm going to append this neighbors by starting from the closest one, then the second one, then the third one. Okay, so starting from the distances, I'm going to append from the neighbors. I'm going to take from the distances. Okay, this is the first closest one. Let me take the data points and the data points corresponding label. I'm going to explain this in a moment. Just give me a second. Again, I'm writing things very explicit. Okay, so let's say I want to pick the first 3 neighbors, the first closest 3 neighbors. This for loop is going to run for 3 times. And the first time, I'm going to pick the very first distances, the very first neighbor. Remember, distance is already sorted out. That means the first member is going to be the closest one based on the distance. And what is this 0 here? It is, remember, this is the first guy, let's say. 0 is corresponding to data point itself. 0 is corresponding to the data point itself from this tuple, and then 1 is corresponding to its label. I'm excluding distance here. So neighbors, inside the neighbors, I'm going to have tuples. Each tuple is going to be the data point itself and its label. Okay, perfect. So I got the neighbors already. Wow. Remember, I'm trying to find the neighbors. So I found the neighbors. So let's return these labels. Okay, I'm done with this function. This function gave me the closest k neighbors from my training data set to this specific test data point. That is correct. Thank you. Either I should have changed I to k or k to I, but Travis, thank you so much. Okay, I'm done with finding the neighbors. So let me go back to my prediction. Remember, that's how we came from. Oh, by the way, before we go back to prediction, let's finish this business with Euclidean distance, because that will be wrapping up all this finding neighbors business. So to find the distance, I need 2 data points, right? So let's call this test row and train row. Remember, test row, and this is a single data point. This is another single data point. This is the data point that I'm trying to predict the class for. And this is one of the training data points that I'm trying to find the distance between this training data point and this test data point. Okay. So it's an Euclidean distance function. Basically, it's very simple. So again, I'm writing everything very explicit. So let's assume that distance is 0. Okay, let's assume that distance is 0. And then I'm going to go over, remember, each data point has multiple features. Like here, I have 4 features. I'm going to go feature by feature. So let me write what I'm trying to do. Let's assume that these are my 2 data points. This is row train, not train row. Okay. And then this is test row. Okay. So I have 2 single data points. So what I'm going to do is I'm going to take the first element of train row, which is x11. This is the first feature. And I'm going to take the first element of the test row. And I'm going to subtract these guys from each other. And then I'm going to take their squares. Okay. And I will repeat this for each element. Again, we can simply do some vector operation here. I know that, but let's write things explicit here so that we understand what is going on. Okay. Okay. So, and then I'm going to find these squares and then add them up and then take the square root of the summation. That is Euclidean distance. So let's do it here. Of course, because index is starting from 0, I'm going to subtract 1 from the length of the training sets. Okay, and then I'm going to simply subtract test row I minus train row. Okay, this subtraction happened, and then let me take the square of this. Multiply 2, that is a square. And I'm going to be adding this to distance, right? Distance plus, right? So I'm going to go over each and every pairs of the features, subtract them, take the squares. And then finally, I will return the total distance to the power of 0.5. Right? That is the Euclidean distance. Any questions? No. All right. So we found the distance. Right? We got the distance. I hope it is okay. Right? Okay, it looks okay. And then given this distance, we found the neighbors. So let's continue with our prediction. So remember, that's where we left. We're trying to find the predictions, find the neighbors. So neighbors for this specific test row, which is a row from my test data set, I'm going to use my function here, find neighbors. Okay, find the neighbors. And for neighbors, as you see, I need the test row. Okay, here's the test row. Okay, I got the test row. All right, and I got the neighbors. Perfect. So from these neighbors, I need the classes of these neighbors now, right? So I need the classes of these neighbors. Let's call this classes. Neighbors classes. Let's call it neighbor classes. Okay. Remember, these neighbors are tuples of the data point itself and its label, right? Data point itself and its label. That means I'm interested in the labels now. Okay, so that's what I'm gonna do. From neighbors, I'm gonna take from neighbors is a list of tuples. I'm interested in the second element of each tuple. That's what I'm gonna do. For row in neighbors, again, I'm gonna use this list comprehension here just for you to practice. So I'm gonna pick a row from the neighbors. Remember, neighbors is a multiple k number of neighbors, okay, k number of neighbors. And then I'm now looking into each neighbor, okay. I will pick the last element from each row. Again, each row is a tuple. Each row is a tuple. I am picking the second element from each row. You're welcome, John. Okay, now I got the list of the classes of my neighbors. All right, perfect. Now I need to find the majority of these classes. Look, number of classes is going to look something like this. Let's say the classes are colors, okay? Different colors. Let's say red, yellow, green, red. So these are the colors of the closest 5 neighbors. And then here is this flower, okay, test flower. I want to predict this test flower's color. Let's say I don't know its color. Let's see, okay? So what I'm gonna do is I'm gonna find the closest, in this case, 5 neighbors. What I'm gonna do is I'm going to take the majority of these classes of the neighbors. What is the majority? Red. Then test flower is predicted to be red. So now this n classes is a list of classes, okay? So again, in this case, class is red. It can be 0, 1. It can be senior, junior. So depending on the context, depending on the problem. So that means I need to find the majority. In other words, I'm going to find the mode of this list, right? So again, there are different ways of doing this. You can use mode, but what I'm going to do is I'm going to take this number of classes. I'm going to turn it into a set. What happens if I do that? Let me show you that. Let's say my list is composed of some numbers. You don't mind me giving a lot of deviations from the code and then giving some examples, right? So this is my list. Okay, it's a list. Now I can turn this list into a set. So let's see what happens. So remember, right? If it is a set, I'm not going to take the repeated, elements. So 2 is repeated 3 times, but when I turn this list into a set, it's going to be shown only once. Okay. So again, there are different ways of doing this, but I will use this way. Okay. Okay. I turned number of classes into a set. And then what I'm going to do is from this set, I will find the element of the set which appears the most in my list. So for that, I will find, I'm going to find the maximum from this set, okay, with the key. I'm going to explain this in a moment. Number of classes, doesn't count. I'm going to explain this in a moment. Okay, let's go back to our list, my list. Um, my list count should be. Okay. So I'm counting. Okay. So I'm counting how many times 2 is appearing. I was confused for a moment. I'm counting how many times 2 is appearing in my list. And let's assume that I'm doing this for each element. Okay, here I know that 2 is appearing 3 times. And then let's assume that I'm doing this for 4 and then 1. In other words, I turn my list into a set. Each element is appearing only once. Now I'm saying 2 is appearing 3 times, 1 is appearing once, 5 is appearing once. So I'm going to pick for one of these elements which is appearing the most in this list. So for that most, I'm using this count function. Okay, that's what I'm doing here. This maximum is, I'm finding the element with the maximum number of occurrences in the list. I hope this was clear, guys. Okay. That's going to be my prediction. Okay, that's going to be my prediction for this test data point. Let's see if I got everything right in here. I don't need this extra. Okay, I got my prediction. Okay, now I'm going to append this prediction into my list, prediction list. Okay, let's take a moment here. I know you guys are tired by now. Let's take a moment here and then see what we are doing. Remember, I got a number of data points. X test is a matrix. It comes with a number of data points. I will reach it just 1 second. And then I'm going through each and every row in this matrix. For each row, I'm finding the neighbors. And from these neighbors, I'm finding the nearest k neighbors. And then I am picking the classes of these nearest k neighbors for each data point from my test data set. And then I'm taking the majority of the classes from the nearest k neighbors for this specific test data point. And that is going to be my prediction for that specific test data point. And then, of course, I'm putting my prediction for that specific test data point into a list. So this list, PRED, is holding my predictions for all my test data points in X test. So Richard is asking if I can scroll up to Euclidean distance. Sure, it's right here. I hope this part was clear. Okay. Now we are done with fit, predict. I think it is time for us to get the score. So of course we're going to return prediction. Go outside. Okay, now let's do the prediction. Score. Okay, for score, what's the time? I will finish in 10 minutes. Okay, I'll finish in 10 minutes. For score, I need my test data set and also the corresponding labels. So why? I'm going to predict Y hat test for each data point in my test data set, and then I'm going to compare my predictions with the true labels. Remember, that's what I said here. What did I say? Y hat and I mentioned, yeah, here. Y hat is my prediction. Y is a true label. I'm going to compare these two. Okay, perfect. All right. So for score, I'm going to say that Y hat is, I'm going to predict Y values for my X test. Y hat is, I'm going to use my predict function. Here, my predict function. I'm going to put my X test data set here. Okay. So this is my Y hat. Okay. Next, I'm going to compare Y hat with Y. Again, there is an easy way to do this, but let me be very explicit about that. Correct is 0, and I'm going to do this in a for loop, okay? For I in range of length of Y test minus 1, right? So I'm comparing each and every data point one by one, okay? Again, there is an easy way to do this. Let's not get into it. If y test I is equal to y hat I, if that is the case, then I have a correct prediction, right? Then correct right? I'm going to increase my correct by 1, right? So after I find all the correct number of corrects, this is correct. What I'm going to return is you divide correct by the length of y hat. Okay, you're going to divide number of correct predictions by the length of your y hat. Okay, that's all. So I think we got everything we need for this KNN classifier. If we made any error at some point, it's not gonna work, and most likely we may have made some error. It's very likely, but it's okay. I know that if you just fix those bugs, I know that it is working. So before you guys leave, let's just test it. Okay, let's just test it from scikit-learn data sets. Let's import load iris. Okay, so this is the iris data set. I'm gonna say iris is load iris, and x will be what iris dot data, and y will be iris dot target. So I have the feature set, I have the labels. Okay, now let me split my data into train and test. So from scikit-learn model selection, import train test splits. Okay, so x train, x test, y train, y test. This x. I know I'm tired. You are tired too. Just a few more minutes. Okay? Train, test, splits, and x, y, and then let's also select a random state so that we can replicate this study. Random state, I don't know, some number 25. Do this. Oh, before we need to do this. Okay. Do you usually email this notebook? I don't, but we can arrange it for those who attended this study. So maybe we can email the notebook. Okay, I got my train data set. Now it is time for us the moment of truth, right? So let's see if it's gonna work. So this is my classifier. Okay, let's first instantiate our class KNN classifier. Okay, remember this is how we called it, KNN classifier. And then let's assign a number of neighbors here. Let's see if it's work. And it gave an error. KNN classifier. Let's make this big. Okay, so I instantiated my, so you type that in the score function rather than y hat. Okay, y hat, that's correct. Thank you. Thank you, Matt. Okay. All right, now let's train our data set. So that's one dot train, okay, x train, y train. Work, and object has no attribute train because it has fit. Now, because I'm let's use this because I am trying to finish this quickly. I'm making errors. So now let us score. Okay, find the score because we know that if score works, predict is also working. Okay, score x test. And the number of neighbors, yeah, we made some errors here, right? Where is that? And self number of neighbors, the very top. Here. Okay. And now what? Distances, neighbors. I see. So I need to put it inside the parentheses. This one. Let's put this inside the parentheses so that I am storing tuples in the list. Okay. You see, there are a lot of bugs, right? So still bug. Y hat. Y hat is not defined. Okay, let's see. Suddenly Y hat is here because I need to have this one. Okay. It's extremely low. We did something wrong. Probably we did something wrong. It's extremely low. No test size. Yeah, I mean, it's okay. We just use the default test train and test split. I think it's 75% and 25%. A KNN classifier takes no arguments. You need to put number of neighbors equals 3. So this is not correct. So something is wrong in here. It should be a lot higher than 0.026. I know that we made a slight small mistake here, but let me not waste your time with that. So let me see. This is my class notes. Okay, so this is what I prepared. I tried to do the exact same thing with you guys, but apparently I made some mistake when I was typing the code. Let me show you how it is working here. So this is what I did when I was getting prepared for this class. So as you see, it is giving me a 94% success rate. And then I compared this with scikit-learn's k-neighbors classifier. Of course, scikit-learn's k-neighbors classifier is much better, tuned up, but it is giving comparable results. For this random state 25, it is giving me the same result, but if I change random state from 25 to say 5, it might give me a different result. Let's see. Oh, it gave the same result, but again, depending on how you split the data set, scikit-learn is giving a better result, slightly better result. Okay. All right, so let me stop here. Let me show us the class code again. Sure. So this is the code that is working. All right, I made a slight, some small mistake in my code. I don't want to waste your time. I'm pretty sure that it's a very small thing. You can find it out yourself. But this one is working. So I just did this morning. It is working. Okay. All right. Thank you so much for listening. In the score method is the return. Let me see. Let's go back. Maybe we can find the return correct. Yeah, because we need to go outside the for loop. Right? Thank you so much for Ephraim for correcting me. I hope it's gonna work now. Let's see. Yep. Okay. As you see, it's a very simple mistake, right? Okay, I'll see you guys maybe next time. We have another workshop next week, but it's gonna be different. I'm gonna be solving some statistics problems for interview preparation. So if you're interested in, so you can stop by. Okay, thank you. Take care, guys. Bye.